My name is Mohsin Mullah, and in this video lecture I'm going to talk about schematic and wiring diagram of motors. So basically any electrical circuit can be represented by two types of diagrams. One is the wiring diagram and another one is the schematic diagram. Okay, so likewise for motor control circuits we can also draw two types of diagrams, such as the wiring diagram as well as the schematic diagram. So now we are going to talk about, particularly in this video lecture, about the wiring diagram and schematic diagram of three-phase induction motor control circuit. So now we know that the three-phase induction motor can be started by various methods. Like the first method is online direct method, second method is auto transformer method, and the third method is star delta starter method. So in the first, we are going to see about the first method in this video particularly, and in the coming videos we will be seeing about the other methods also and the related schemes of starting for those different methods. So now coming back to the topic that we are going to discuss is direct online starting of three-phase induction motor. So now direct online starting of the three-phase induction motor means when we want to start the three-phase induction motor, directly the supply will be three-phase supply, that is the rated voltage of 415 volt will be connected to the terminals of the motor. Okay, the three terminals of the motor will be directly connected to the three-phase supply of 415 volt at the time of starting. So there is no intermediary value, directly 415 applied to the terminals of the motor. Now this can be achieved just by using a simple triple pole switch, but to incorporate motor protection against overload, so we need to consider some protection part also. Therefore here we are going to consider overload thermal relay along with the electromagnetic contactor for the control as well as protection of the three-phase induction motor. So here is the wiring diagram of direct online starting of three-phase induction motor. So just let me just walk you through all the connections of this diagram here. So basically for three-phase induction motor here, which is represented, so we require the three-phase supply. So the three-phase supply are given by this three-phase connection RYB, and then there is a neutral. So now three phases are tapped from here, and these needs to be connected to the motor three terminals. So now before they are actually connected here, we need to incorporate the control and the protection circuit in between. So that is done. So these three supplies are taken, and here in the beginning itself the fuses are connected. So fuses are used for additional protection in case of unwanted conditions, such as there is a short circuit or any other kind of unwanted situation. So that will be protected if the fuses are placed here in the connections. Then there is this electromagnetic contactor. So this electromagnetic contactor will be usually in open condition, but when it is energized, in that case it will be closed, and this will make the connection with this upper terminal and lower terminal, so that the upper R phase is connected to this first terminal, Y phase is connected to second terminal, and B phase is connected to the third terminal here. Then from that terminal again it is not given to the motor directly, then there is a protective part which is the thermal overload relay. So this is placed in the three-phase connection here. So now what does this thermal overload relay does is, when there is overloading of the induction motor, so in that case high current will start flowing through the supply terminals. It will start when there is a overload. So because of the increase in the load, it is going to draw more current here. So when the current increases in the input terminals, automatically the heat generated by the current here will be larger. So because of the larger heat, so the relay will sense that increase in the current, and hence it will sense that there is overloading. So it will generate a signal to open the neutral terminal which is connected here. Okay, so we will come back to that part now. So therefore we need to understand that before we directly give the three terminals of the supply to the motor, we have to provide a contactor which can be operated, and there is a protective relay. Now how this contactor is operated, for that we need to have a control circuit. So now this section is the control circuit of this motor, starting of the motor. So basically for the control circuit we need to have the start and stop buttons. Okay, so that is connected with the help of different elements in a, you can say, electrically in a completely controlled, can say proper controlled, and a proper electrical circuit connection should be made for that controlling part. So therefore, for do that, so here one of the phase is taken. Okay, so now this phase is connected with the help of one fuse to the first push button, which is stop button B1, and then this is connected again to the second push button. So the first push button is normally closed condition. Okay, so here it will be always in the closed position. Okay, so when we want to stop the motor, in that case it is pushed, momentarily it will be disconnected, but again it will come back to the original condition. So normally closed condition. Then this phase is connected to B2. So here there is second push button. So now you can see here the phase terminal is connected first terminal of the contactor, then the lower terminal is connected to the second terminal of the contactor. Now no lower terminal where it is connected, if you trace this connection, it is connected through one fuse to this contactor, which is connected to the neutral. So here the other connection is neutral. The first connection is phase, then the other connection is neutral. So when this push button is pressed, B2 is pressed, so the phase and neutral are connected, hence this contactor will be energized, and when this contactor is energized, the electromagnet will be energized, and when the electromagnet is energized, it will be pulled towards the contacts, these terminals, and it will engage the two terminals together. So that is, these two are now connected with each other. So these are directly online, these three are directly online, and when suddenly suppose there is de-energization of this contactor, so this electromagnet will be released and it will come back to the original position with the help of the springs attached to this contactor here. Okay, so now how it will work? So when we want to start the motor, so we are going to push the start button B2. So when it is pushed, phase and neutral connection are going to connect to the contact, and it will energize the contactor and the motor will start running. Suppose the motor is running on the normal load, so it will run continuously as long as we want it to run, or we stop it, or there is no supply. Okay, and suppose the motor is overloaded. Okay, so it may happen that the motor will become overloaded. In that case, so this relay is going to sense that overload, and it is going to generate the signal to open the neutral connection here. So it will disconnect the neutral connection. So therefore here the second terminal of the push button is disconnected, hence it is contact is de-energized, and electromagnet will be released and it will go back to its normal open position. Okay, so that will happen. And similarly, sometimes what will happen, there will be a short circuit. So in short circuit condition, the relay will not be able to sense that short circuit in a less time, or say it does not act very quickly, which is very much essential in case of a short circuit condition. So there is an auxiliary circuit provided to take care of any short circuit, which will be connected to this push button B1. So when there is a short circuit, so this push button B1 will be, you can say, it will become normally from close to open condition for momentarily, and when it becomes normally open, so that time again this coil will be de-energized because the phase is disconnected, and it will be released. And again when the electromagnet is released, so therefore this relay will sense that zero current, and it will release, or you can say the whatever short circuit auxiliary circuit is there, so that will sense that there is zero current, and it will release the contactor for this stop button, and it will again come back to its original closed position. Okay, so thereby again becoming the means this upper terminal and this lower terminal will be always connected in the stop button as long as we want it to be connected. Okay, so now suppose the motor is running safely. Okay, so it has been running for a very long period of time, and now we want to stop it. So we are just going to press this push button, stop button. So the phase connection will be disconnected, therefore this contact circuit will be de-energized, and the contactor will become normally open again. Okay, so like this it will be operated, as well as with the help of this thermal overload relay it will be protected. Okay, so I hope you have understood the working of this simple starting of the three-phase induction motor, as well as the protection against the overload condition, as well as under the short circuit condition. Now the second important thing is to draw the schematic diagram. So now let us see how we can draw the schematic diagram. Now schematic diagram is very important because it will directly show us the working in a very simple way. Okay, so we are going to see that here. So basically the control circuit schematic diagram needs to be prepared, as the three-phase induction motor connection and the representation of the three-phase induction motor is going to remain same in all the varieties of schemes. So only changes are with regard to the protection and control circuit. So therefore the schematic diagrams are used here only to represent the control circuit. So now if you trace the control circuit from the phase till the neutral, you are going to get the schematic representation of the control circuit here. So let me show you how to obtain that. So first there is a phase. So that phase B is connected here, and it is going to carry the single phase voltage of 240 volt. Now from that there is a fuse connection. Okay, so here fuse is used E1. So after that there is first push button. So that first push button is normally closed push button. Okay, so that is for off, keeping the motor in off. So that is B1, and then there is the second push button terminals directly, B2. Okay, and this is the contactor push button contactor for that B2, so which will make the motor on when it is pressed. Okay, and this terminals will be connected to the contactor here. So that contactor is represented by C. Okay, so then the lower terminal of the B2 is connected to the neutral. So that connection will go through first the fuse E2, and then it will go to the contactor C, and it will be connected to the neutral point. So therefore it will first go through the uh, fuse E2. Now this fuse E2 is going to be operated from the signal coming from thermal overload relay. In that case only it is going to operate, otherwise it will be closed only. If in normal condition is there, it will be always closed. Then from there it is contactor, it is connected to the contactor, and finally the other terminal, which is the neutral terminal, is connected from here. So this is the contactor C. Okay, so this is the schematic representation of the control circuit of the three-phase induction motor, started with the direct online method. Okay, so I hope you have understood the wiring diagram as well as the schematic diagram of the direct online starting of three-phase induction motor. So in the coming videos we are going to see different controlling scheme of the same three-phase induction motor. Okay, so I hope you have understood the concept that I tried to explain here. And if you like the content, please like the video, and it will encourage me to prepare more such type of videos. Okay, and hope you will prepare well for your examination based on the content of this particular video lecture. Till then, happy learning.